Good morning, afternoon, or evening, wherever you're watching this video from. My name is Adam Almasri. I'm here alongside my peers, Sophia, Paula, and Alyssa. And we're here today to present our social responsibility presentation. This presentation is originally adapted from the AutoDrive, or the SAE AutoDrive Challenge Year 3 presentation, in which our team was expected to present our version of a report that discussed a few topics. First and foremost, the various impairments and or disabilities that individuals face that create barriers of accessibility in transportation systems, and as well as discussing or as well as proposing a particular standard amongst autonomous vehicles that could address those barriers, and proposing a plan of action to actually implement that standard based on the variety of stakeholders that we are concerned with in autonomous vehicles. Today we'll be presenting something very, very similar. So we will start by discussing auditory and visual accessibility in transportation and how auditory and visual impairments affect individuals in accessing all forms of transportation, specifically in the United States, with some Canadian stats thrown in. We will also be discussing autonomous vehicle ride sharing as a solution to addressing these barriers and providing a view on some of the standards that we presented in that paper. And then we'll discuss a plan of action or our plan of action specifically for how we can begin to implement these standards. I do apologize. I should have noted that we are from the University of Toronto and we represent a team called Toronto. And our vehicle's name is Zeus, and this is the logo of our team and our vehicle. So we'll begin by discussing auditory and visual accessibility in transportation, and I'll pass it off to my colleague to begin.
Okay, we're going to start off this presentation by providing an overview of our target demographic and giving some context as to why we chose this specific demographic. According to the US Census Bureau, of the 329.5 million Americans, 56.7 million live with a disability. This comes out to being approximately 1 in every 6 Americans. Of those with disabilities, about 12.5% have auditory impairments, while 14.3% are visually impaired. And the reason we chose to focus on these two impairments is because, in addition to the fact that they combine to make up over a quarter of all impairments, they are also two of the impairments that are less accommodated for in terms of the structure and flow of our mobility ecosystem, as we will go on to show in future slides.
So as Sophia mentioned, those are two impairments that are often not well addressed in many forms of transportation. We'll discuss first and foremost driving, which is one of the most common forms of transportation. One obvious form of an accessibility barrier is license restrictions. Individuals who fail to pass a vision test or have a lower score than average on a vision test will have restrictions placed on their license, which may prevent them from driving at certain periods of time, such as at night or under certain conditions. Worse, there are many individuals who cannot access a license because they cannot pass the vision test, and as a result are unable to operate their own motor vehicle. We consider individuals with auditory impairments with respect to driving. They have their own set of challenges. For example, they are more likely to have negative police interactions. And what we mean by that is a typical traffic stop where the police officer might take 10 minutes. On average, these traffic stops for individuals with auditory impairments grow up to 40 minutes. That's because the officer and the individual have trouble communicating with each other. In the worst situation where an officer might issue an emergency order or command, where the two individuals are not able to easily communicate with each other, that could lead to a dangerous situation because the individual with an auditory impairment might not be able to understand that command and reply to such a command. If we consider public transit and or taxis, we face the same notion of accessibility barriers. So take, for example, inaccessible transit infrastructure. Well, without loss of generality, let's consider the example of a streetcar, which is a form of public transit that operates in the middle of the roads with a dedicated rail. If you consider someone who has a visual impairment, What we're essentially asking to do is try to board this vehicle in an active traffic situation where they're responsible for their own safety, crossing potentially one or multiple lanes of traffic in order to board that streetcar. Same thing might exist if you consider a subway vehicle where there are gaps between the platform and the streetcar and the subway. Many of these individuals may have access to personal assistance or seeing eye dogs, but that's often not the case because both are fairly expensive and that cost is prohibitive to many individuals. In the case of seeing eye dogs, there's often a lengthy wait list in order to be able to access one. Now, we might argue then that many public transit systems have auditory and visual cues that allow these individuals to navigate with ease, but that isn't entirely true. Take the Toronto Transit System, for example, here on the right. There are some stations or vehicles that still do not have digital systems that help individuals navigate. So there might be analog systems like maps, or require a driver to speak on an intercom system to be able to tell you what's happening. And the digital systems that do exist are not entirely consistent and provide information in a variety of forms. And it's those inconsistencies and the lack of uniformity across the system that can make it difficult for an individual with either visual or auditory impairments to easily navigate that system. If we consider taxis, well, taxis are no different than a personal vehicle, but in this case, you're not operating the vehicle. You're entirely reliant on another individual to help you enter the vehicle, go through your ride, exit the vehicle, and not all taxi drivers may have the requisite training to be able to support individuals with a varying degree of visual and auditory impairments. So then we might presume that autonomous ride sharing is an interesting solution to addressing these barriers of accessibility. Purdue University states that sees the need for a universally designed autonomous vehicle that is built accessible from the ground up. Moreover, AV design should provide a complete independent travel experience for as many riders with disabilities as possible. And so the argument here is twofold, that autonomous vehicles can in fact provide a fully accessible experience for individuals with a wide variety of disabilities, including auditory and visual impairments. But in order to accomplish that, it is important that we design these autonomous vehicles to be accessible from the ground up, and that the system in which they're employed is also accessible. So how do we accomplish that? Well, let's go through a journey of what a conceptual autonomous vehicle ride sharing system might be like today, what the barriers are, and how our proposed standard could potentially provide solutions to address those barriers.
So now we're going to consider a typical rideshare experience. So this process can start by hailing the ride, and this can be done directly through a digital platform. For example, this digital platform could be a mobile application or a website. You would then proceed to do the following steps. You would open the application, you would select your destination, and then you would select your ride type if you're required. You would lastly confirm, and then you would wait. Now, if you're an individual with visual impairments, this process is not going to be the same because you might have difficulties operating this mobile application. For example, you might not know how to select the ride type or the pickup location or even the destination, as it is mainly a visual and tactile experience.
So, how could we potentially address those barriers? Well, first and foremost, we can ensure that all of these mobile apps or digital systems that are required to access some form of a ride sharing system enable text to speech. And so that allows individuals with visual impairments to be able to easily understand exactly what is occurring in the app, especially if they're using accessibility devices or devices that have accessibility support. Moreover, we would impose a standard that asks that all of these applications follow WCAG guidelines, which are often designed to enable accessibility devices to be fully supported on the web. With that said, it should be noted that there's only one ride-sharing app that we are aware of that currently fully respects the WCAG standard and is as a result fully compatible with a wide variety of assistive devices. So let's consider the next step in a typical ride sharing scenario, and that's waiting for a ride to arrive and entering that ride. If you consider sort of a typical scenario, it's waiting for the car to arrive while you're looking at your app and sort of tracking it on a GPS system. Maybe the driver stops exactly where you expect and you recognize the vehicle information from the app and you enter. Oftentimes, that doesn't always happen. Drivers can't always stop in the right place for whatever traffic reasons are causing whatever impediments. And so maybe you have to contact the driver and negotiate a new stop that allows you to be able to enter the car. But inevitably, you'll manage to locate the car and enter it. Well, what are the barriers to consider in this regard? Well, it's that obvious one of the car does not stop where it is expected to stop based off of the location set on the app. So if you consider someone with a visual impairment, this presents quite a few challenges. Now, if the car stopped only a few meters away, maybe, or a few feet away, that might not be problematic. But if it is stopped dozens of feet away, it may be difficult for that individual to navigate to the vehicle, especially if the vehicle isn't stopped directly by a curbside where it is safe to enter. Again, forcing an individual to potentially navigate an active traffic scenario. This might also be the case for someone who has an auditory impairment. If they're unable to locate the vehicle visually based off of what they see in the app and what they see in the world, well, they'll have to contact the driver, and that might be difficult to have a conversation. So, how do we address these particular barriers with our proposed standard?
So, when considering solutions for entering the vehicle, we asked ourselves the following questions. So, how would the rider know when the ride is there? So, upon arrival, the car can make noises to notify him or her, and as well, audio cues can come from the mobile application that is being used in a sort of way of like informing the user of the device's proximity to the vehicle. Additionally, to facilitate the vehicle entrance for individuals with visual impairments, we can implement braille labels on the vehicle's handles as a way to let the user know of the door locations. The next step in a typical rideshare experience is what occurs during the ride. So this typically means the ride's environment. While in normal conditions, like this would mean comfort, being aware of your surroundings, and the engagement that you can have with the driver. Now, considering the barriers, individuals with auditory and visual impairments might not be able to have such interactions with the driver. They might look outside the window and not know their surroundings, and they can be unaware of any emergency occurrence, which is essential to know.
So, how do we address those particular barriers? Well, first and foremost, we have a wide variety of feedback systems that provide any rider a sense of awareness around that particular trip. That include descriptive audio that could describe the current progress of the trip, turns that are being made, as well as stops and acceleration. An accessible monitor display that would present very similar information, and touch sensory feedback built into these seats or potentially the doors to provide the user a sense of how the trip is going. And this is something that not only supports individuals with auditory and visual impairments, but can make the ride more accessible to all individuals. In the worst case, there would also be an emergency stop and support button that would force the vehicle to safely stop and allow the individual to engage with a digital support system if needed in the case of an emergency that may or may not require first responders. Now, if we consider the next aspect of a typical ride sharing journey, it's arriving at your destination, exiting. And this is not dissimilar from waiting for a vehicle to arrive and entering. But it presents its own challenges. And many of us have obviously been passengers in ride sharing systems. And occasionally we are not able to stop at the exact destination we need to stop. Sometimes we can't also stop at a curbside. And so we're forced to disembark the vehicle in an active traffic scenario. How could that present barriers for other individuals? Well, again, it's very similar to arriving. First and foremost, if the car is not stopped in the location that it is expected to stop, well, then an individual with a visual impairment will be at a disadvantage in terms of trying to navigate where they are right now to their final destination. Moreover, if you consider the fact that those of us who are forced to disembark the vehicle in an active traffic situation, well, we are able to visually verify our surroundings to ensure that maybe there aren't any cyclists or there aren't any other vehicles that will get in our way and that we can exit the car safely. That presents yet another barrier and a problem for individuals who might have a visual impairment, and the same may exist for individuals who have auditory impairments. So how can we address these specific barriers?
So then we provided a solution in the following way. So a monitor display can serve as a way to communicate and inform the users of the arrival to their selected destination. The monitor can do that through audio and visual cues that activate when the ride has ended. At the same time, exiting the vehicle in unsafe locations such as incoming traffic or cyclist lanes are big safety hazards that we considered. Therefore, to prevent any accidents, the vehicle will only drop off users in appropriate drop-off locations with a space clearance of about 2 meters.
In the worst case scenario where our standard can't necessarily address all possible barriers, and especially in emergency scenarios, our standard also proposes the notion of live support and specifically tiered services. This could start with an automated chatbot and could progress to live support either through a chat system or through a conversation on the phone. And if required, the service staff on the other end can dispatch a support worker or support staff to be able to provide roadside assistance, which is already a system that exists today. So then, we've discussed what are some of the most significant barriers in transportation and how autonomous vehicles could potentially address those barriers. But we need a plan of action to legitimately implement these standards and to move forward in a way that brings together all the stakeholders who are concerned with the development of new mobility ecosystems. And in doing that, we have to consider a few things. First and foremost, the set of values that may drive the decisions and the actions of our stakeholders. And those stakeholders uh, are everything from engineers to legislators, and unfortunately our slides are slightly cut off here in PowerPoint, but mobility solution engineers, the individuals who are concerned with developing the vehicles and the systems on the vehicles, legislators and underwriters who are responsible for developing legislation and regulatory frameworks, road and transportation safety experts who are first and foremost concerned with road safety and access to the road, community advocates, and the businesses and corporations who will be driving the development of all of these technologies. So let's start with our first value system, which is design feasibility. And that first and foremost is the concern of mobility solution engineers. So those individuals who are developing autonomous vehicle technologies and corollary technologies. And the road and transportation safety experts who are responsible for our transportation infrastructure on which these autonomous vehicles will operate. Now, when we're talking about design feasibility, we're really talking about emphasizing or upholding certain goals and values. First and foremost, this notion of functional implementation, that any design standard or proposed standard has to be feasible in its implementation. Moreover, we're discussing the idea of a standardized design. So in our proposed standard, we don't prescribe the specifics of the technology, but we do propose a standard that ideally numerous sets of technologies can reach in a standardized fashion. Minimal risk of failure is always important when we're discussing innovative or novel technologies, and that's this idea that these technologies have a very, very low risk of failure, and that's to ensure the safety of all. And that all of these technologies and systems can be manufactured at scale. It's not enough to simply be able to have a feasible design, but one that can feasibly be scaled in order to meet the size of the mobility ecosystem we're discussing here today. So how does our design actually address these values?
Our designs will address each of these considerations in several ways. First, we plan on reusing the majority of our vehicle's existing infotainment system, such as the center console and in-vehicle audio systems, to emulate what we've seen industry leaders doing. We will also incorporate our solutions into the vehicle using a phased implementation approach, and our designs have been validated through other companies' implementations of similar solutions. Four notable examples come from Uber, Tesla, Waymo, and GM. Uber developed an accessibility application for their rideshare service, which demonstrates a similar level of commitment on their end to rider inclusivity. Additionally, Tesla introduced the idea of replacing the dashboard with a larger screen, and Waymo incorporated an interface in their cars for backseat passengers. GM has also made significant strides in the autonomous vehicle industry by introducing their safety alert seat, which vibrates when obstacles are nearby. Toronto has derived inspiration from each of these examples and we've been working to incorporate similar solutions within our own autonomous vehicle.
So if we consider the next value system, its economic impact. Obviously, any proposals around a new era of transportation can potentially come with massive economic impact and gains. And economic impact is primarily, no, not primarily under the purview of, but is often considered by the legislators and underwriters who will be developing legislations and regulatory frameworks that have a direct impact on our economy. And the legislators and underwriters often will consider what community advocates have to say. So individuals who represent our community members in terms of their ability to access fair transportation, but also have the ability to access a growing and new economy. And the businesses and corporations who will be responsible for developing these technologies and will effectively be driving that economic impact. So when we're talking about economic impact, there are a couple of considerations and aspects of these considerations that we will try to encourage or incentivize. Well, first and foremost, it's this notion of an accessible economy. That means that the introduction of new technologies should also mean the introduction of a more accessible economy as it grows. And that gets us into our next point, the idea of job growth. Any aspect of our standard, ideally a successful standard, will be one that will create jobs or at least propose technological solutions that will enhance or increase the number of jobs that we see. Last but not least, the idea of satisfactory regulations. And that's this careful balance amongst the legislators and underwriters to create regulation that will ensure that we develop systems that are safe and accessible for all, but also balance the needs of businesses and corporations that will be operating under these regulatory frameworks and will be driving the innovation development of these technologies. So, how does our proposed standard tackle economic impact?
The central motivation of Toronto's social responsibility team is to increase rider mobility. A study has shown that 29% of people with disabilities don't drive, and within this demographic, 45% choose not to or can't because of their disability. This becomes especially cumbersome when they can't reach their place of work and therefore earn a living without encountering serious obstacles along the way. Through the accessibility features that we've introduced, we offer a higher level of mobility to passengers with visual and auditory impairments by offering an alternative to public transit. Additionally, with the introduction of these features, we're opening the door to new types of jobs, such as in-vehicle support agents and vehicle engineers.
Any proposed standard has to consider the viability of a business because, again, businesses and corporations will be the ones driving the development of these technologies and will be the ones that most likely will be financing both partially the research and mostly the creation of such technologies. And it's legislators and underwriters who will be responsible for, again, creating the legislation and regulatory frameworks that will guide how this can be done. And so there's a careful balance to be had to ensure that any proposed standard maintains and potentially increases the viability of any businesses involved in autonomous vehicle ride-sharing systems. So what do we mean exactly by business viability? Well, it's first and foremost a high return on investment, whether that's an investment on research or an investment on the development of such technologies. Obviously, any company would like to see that its bottom line is growing as a result. That gets us into profitability. That ensures that as these technologies are being built and as these businesses are investing more in these technologies, they are able to access profitability through this work. Scalable businesses. So as we propose a design standard that technologically should scale, it should allow for businesses to be able to scale to meet the growing need in mobility solutions. And last but not least, as we've said earlier, our design standard doesn't prescribe the specifics of the technology, but rather what the technologies are intended to achieve. And that's important to ensure that markets stay competitive and that companies can constantly innovate and build novel and unique technologies while still meeting a particular standard. So how is it that our proposed standard incentivizes or aims to achieve this?
The accessibility solutions that we proposed, such as the additional display unit and the tactile feedback built into the car seats, do incur additional costs per vehicle manufactured. However, these costs are justified in the sense that they enhance rider safety, improve the overall user experience, ensure equal vehicle access, and demonstrate a high level of commitment to social responsibility and user inclusiveness.
Last but not least, it's this general notion of social impact that we are driving towards with our proposed standard. And obviously, social impact is the consideration of all of these stakeholders. And essentially, we are discussing the notion of bettering our societies and the quality of life of our fellow citizens within these communities. What does that actually look like? Well, first and foremost, it's usability. It's the idea that not only are we increasing usability for riders today, but we're able to make ride sharing systems more usable for riders as we progress in the evolution of these technologies. Of course, accessibility is the primary focus of today's presentation, and that is important. We want to always ensure that any proposed standard, um, first and foremost, incentivizes increased accessibility to these transportation systems, because increased accessibility obviously creates greater impact for all. And that gets us to the idea of social responsibility, a proposed standard that makes anything more usable, more accessible, and safer is a socially responsible way, and one that takes into consideration the values of all stakeholders, is a socially responsible way to move forward on any plan of action for these designs. So how do we address social impact through our proposed standard?
Our proposed set of standards afford easier door-to-door access for all riders, regardless of whether they have visual or auditory impairments. Through that door-to-door access, we're lowering the barriers that people with disabilities often encounter on their way to work. In fact, our solutions will create new opportunities for users with disabilities to find jobs that are further than walking distance from their homes or are in locations that aren't accessible through public transit. Additionally, even though we've replaced the need for a driver in our autonomous vehicle, our work has the potential to introduce new jobs, such as rideshare support specialists. Enhancing road safety has also been a primary objective for us, since our users will only be in one car amid many others on the road.
And this brings us to our final point. Our main goal here around accessibility in transportation is really the idea of equity in transportation. Earlier today, we mentioned a statistic that said that 1 in 6 Americans have some form of disability. And within that subset of disabilities includes auditory and visual impairments. And that significantly impacts people's day-to-day ability to access um, transportation in a way that um, enables them to access certain opportunities. With our proposed standard, we are effectively proposing a new and better way forward for all Americans and Canadians to have fair access to transportation, and as a result, fair access to opportunities. And so what you see in front of you is this representation of every American, regardless of what impairments or disabilities they may have, having access to transportation systems that are accessible and enable each and every single one of them to be able to access transportation and, as a result, access the opportunities that they all deserve. Thank you so much for listening to our presentation today.